A projectile is fired at time t equals 0.0 seconds from point 0 at the edge of the cliff with initial velocity components of v on x or v initial on x equals to 30 meters per second and v initial on y equals to 100 meters per second. The projectile rises, then falls into the sea at point P. The time of flight of the projectile is 25 seconds. In figure 3.2a, the magnitude of the velocity at time t equals 15 seconds is closest to. Since the problem is asking us about a projectile, we'll first need to write the equation of motion for a projectile. So we said that x times it's equal to v initial velocity on x times time and y on t is going to be equals to y initial times time plus the velocity on y times the time minus the acceleration times t to the second. From what the problem says, the initial velocity it equals to 30 meters per second. The initial velocity on x, of course, and the initial velocity on y is going to be equals to 100 minus the acceleration, which is, we're going to say is going to be 10, since gravitational force, times the time. So on the x direction, we're going to have a constant velocity, and on the y direction, we're going to have a constant acceleration. So now they're asking us for the velocity at 15 seconds. We know that on the x direction, the velocity is always going to be constant, but the y direction is going to change. But the velocity in the y direction is going to change. So we have 100 minus 10, and we plug in our value of time, which is going to be 15. So the velocity is going to be equals to minus 50. So we know that one way to find the magnitude of velocity is by finding the square root of the velocity on the x. So the x component of the velocity to the second plus the y component of the velocity to the second. So now all we need to do is plug in the values for the velocity on the x component and the velocity on the y component. So velocity in the x component is going to be 30 meters per second to the second plus minus 50 meters per second to the second. So velocity is going to be equals to 58.31 meters per second, and it's closest to 56